Hello everyone. In this video, we are going to see a set of SAT math problems. Here by the first problem. Okay, let's go to the question. The producer is creating a video with a length of 70 minutes. The video will consist of segments that are 1 minute long and segments that are 3 minutes long. Which equation represents this situation where X represents the number of 1 minute segments and Y represents the number of 3 minute segments. Okay, here we have X number of 1 minute segments. Now to find the total amount of time in this X number of 1 minute segments, we have to multiply the number of segments X and the length of each segment, that is 1 minute. X times 1 is we get X. So this X gives the total amount of time in this X number of segments in minutes. Okay, now to find the total amount of time in this Y number of 3 minute segments, we have to multiply the number of segments Y and the length of each segment, that is 3. Y times C is 3Y. Okay, here we can add the amount of time we have in X number of 1 minute segments and the amount of time we have in Y number of 3 minutes segments. So that is equal to the total length of the video according to the information, that is 70. Here I got the equation which represents the given situation. I find this equation in the answer choice D. The correct answer choice for this question is D. Okay, now let's look at the next problem. A chemist combines water and acetic acid to make a mixture with the volume of 56 milliliters. The volume of acetic acid in the mixture is 10 ml, that is 10 milliliters. What is the volume of water in milliliters in the mixture? Assume that the volume of the mixture is the sum of the volume of water and acetic acid before they were mixed. Okay, here the total volume of the mixture is 56 milliliters, in which we have 10 ml, that is 10 milliliters of acetic acid. Then the remaining amount of liquid is the water. Okay, our aim is to find the volume of water in milliliters. For that, we have to subtract the amount of acid, that is 10 milliliters, from the total volume of the mixture, 56 milliliters. When I subtract 10 from 56, I am getting 46 milliliters. Therefore, the volume of water in the mixture is 46 milliliters. Okay, let's look at the next problem. For the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as a coefficient or the base? Okay, in the given answer choices, I have to find the function f of x where the value of k is being as a coefficient or the base. Okay, how do you have to get the value of k? To get the value of k, we have to plug in 1 for x into the function f of x, because here we have the information f of 1 is k. Okay, now let me get the value of k for the function f of x in answer choice A, that is k equals to f of 1. Okay, now we have to plug in 1 now for x over here in this stuff. Then we get 50 times 1.6 raised to the power of 1 plus 1. Then we get 50 times 1.6 raised to the power of 2. Okay, here 50 times, when I evaluate the value of this 1.6 the whole square, I am getting 2.56. Okay, now let me multiply 50 and 2.56. When I do so, I am getting 128. I got the value of k for the function f of x in answer choice A, that is 128. But I don't see this 128 either as a coefficient or base over here. So the function f of x in answer choice A does not display the value of k as a coefficient or the base. So we can reject answer choice A. Okay, now let me get the value of k for the function f of x in answer choice B, that is k equals to f of 1. Now we have to plug in 1 for x over here. Then I'm getting 50 times 1.6 raised to the first part. Actually, the value of this one is just 1.6. Okay, now let me multiply 50 and 1.6. When I do so, I am getting 80. Here I got the value of k for the function f of x in answer choice B. And I don't see this value of k, that is 80, as the coefficient or base over here. So the function f of x in answer choice B does not show the value k either as a coefficient or base. We can reject answer choice B as well. Okay, now let's find the value of k in the function in answer choice C, that is k equals to f of 1 equals to 50 times 1.6. Here we have to plug in 1 for x over here. Then we get 1 negative 1. Then we have 50 times 1.6 raised to the power of 0. Okay, 50 times any non-zero number is raised to the power of 0 is equal to 1. That is, the value of this power is 1. Then we get 50 times 1. Here 50 times 1 is 50. So for the function f of x in answer choice C, I got the value of k, that is 50. And this 50 is being as a coefficient over here. So the function f of x in answer choice C shows the value of k as a coefficient. So the correct answer choice for this question is C. Anyways, let's verify answer choice D. That is, we have to find the value of k for f of x and answer choice D, that k equals to, let's plug in 1 for x over here. Then we get 50 times 1.6 to the power of 1 negative 2. Then we get 50 times 1.6 to the negative first power. Okay, here 50. Since the exponent is negative, now to make this exponent as positive, I have to move this one to denominator. When I move to the denominator, automatically the exponent will change its sign. Then we get to 1.6 to the first power. Okay, here 1.6 to the first power is still 1.6. Okay, now let me divide 50 by 1.6. When I do so, I am getting 31.25. So this is a value of k for the function f of x in answer choice D. But this value 31.25 is not shown either as a coefficient or base over here. So we can reject answer choice D. Therefore, the correct answer choice for this question is C. Let's look at the next problem. The regular price of a shirt at a store is $11.70. The sale price of the shirt is 80% less than the regular price, and the sale price is 30% greater than the store's cost for the shirt. What was the store's cost in dollars for the shirt? Okay, now let me consider this information. That is, sale price of the shirt is 80% less than the regular price. Okay, now let's write this one as an equation. That is, sale price is equal to 80% less than. 80% less than means I have to subtract this 80 from 100. It is 100 negative 80% times the regular price. The regular price is $11.70. Okay, 11.70. 100 negative 80 is 20. That is 20% times 11.70. We can convert this 20% as a decimal. For that, we have to divide 20 by 100. Then we get 0.2 times 11.70. Okay, now let me multiply 0.2 and 11.70. I am getting 2.34. That is, the sale price of the shirt is $2.34. Okay, now what we can do is we can consider other information. That is, the sale price is 30% greater than the store's cost for the shirt. Okay, now we can write this information as an equation. That is, sale price equals to 30% greater than means we have to add this 30 to 100. Okay, here 100 positive 30%. Actually, we got the first information 80% less than, so we subtracted 80 from 100. Here 30% greater than means we have to add 30 to 100 times the store's cost for the shirt. So let's assume the store's cost for the shirt as just Y. Okay, already we got the sale price, that is $2.34. Let's plug in this value for sale price we have over here. Then we get 2.34 equals to, and here we get 130% times Y. Then we have 2.34 equals to, when I convert this percentage to decimal, I'm getting 1.3. That is 130% equals to 130 divided by 100. When I do so, I'm getting 1.3 times Y. Our aim is to get the value of Y, which gives the store's cost in dollars for the shirt. Let me divide both sides by 1.3 to solve for Y. So let's cancel this 1.3 and 1.3. Okay, now let me divide 2.34 by 1.3. When I do so, I'm getting 1.8. So here I got the value of Y, that is 1.8. So we have assumed Y as store's cost in dollars. Therefore, the store's cost in dollars for the shirt is 1.8. Here we have the next problem. Okay, let's go to the question. Function f is defined by f of x equals to negative a to the x to the power positive b, where a and b are constants. In the xy plane, the graph of y equals to f of x negative 15 has a y-intercept at 0, negative 99 over 7. The product of a and b is 65 over 7. What is the value of a? Okay, let's consider the equation we have over here. That is y equals to, and for this f of x, we have the stuff over here. Let's plug in this stuff for f of x over here. Then we get negative a to the x to the power positive b. We can take this negative 15 as it is. Now we can use Desmos to solve this problem, and we have y-intercept for this equation. Since this is a y-intercept, we have this point on the graph of this equation. Okay, let me take this point as input in Desmos. Let's click on positive sign and go to table. The x coordinate is 0 and the y coordinate is negative 99 over 7. Now we have to take this equation as input in Desmos. Here my aim is not to get the graph of this equation. My aim is to find the value of the unknown constant a in this equation. In that case, when I take this equation in Desmos, for x I have to use x1, for y I have to use y1, and instead of equal sign I have to use tilde sign. Okay, now let me take this equation in Desmos. So that is y1, and for equal sign we have to use tilde sign, negative a to the power of x1. Okay, here let me take x1, positive b, negative 15. Now let's consider the other information we have in the question. That is a product of a and b is 65 over 7. That is a times b equals to 65 over 7. This equation contains only the two unknown constants a and b. When I want to give this equation as input in Desmos, I have to solve for one of the constants, and then I have to take that equation as input. I should not take this equation as input in Desmos when the equation contains only the unknown constants. Okay, so here we can solve either for a or b. Since our aim is to get the value of a, let's solve for the constant a in this equation. For that, we have to multiply both sides of the equation by 1 over b. Then this b will cancel out. 1 times a is a. On the right side, 65 times 1 is 65, divided by 7 times b is 7b. Now we can take this equation as input in Desmos. That is a equals to 65 divided by 7 times b. Here I got the value of a. The value of a is 5. Okay, let's look at the next problem. The area of a rectangular banner is 2661 square inches. The banner's length x in inches is 24 inches longer than its width in inches. Which equation represents this situation? Okay, let me write the length. According to the given information, x represents the length of the banner. And let me write width. Let's assume y represents the width of the banner. Okay, now we can consider the information we have over here. That is the banner's length x in inches is 24 inches longer than its width. That is x equals to 24 more than the width, 24 more than y. So it can be written as y positive 24. Okay, now let's solve for y in this equation. For that we have to subtract 24 from both sides of the equation. Then positive 24, negative 24 will cancel out. I am getting x negative 24 equals to y. Here I got the value of y in terms of x, that is y equals to x negative 24. So that is x represents the length and x negative 24 represents the width. And we know that when I multiply the length and width of the rectangle, that is equal to the area. Here the length is x. Let's plug in x for the length over here. And for width we have x negative 24. Let me write over here. And for area of the rectangle we have 2661. Let me plug in this value for area over here. Okay, now we can distribute this x to this x and negative 24. Then we get x square and negative 24x equals to 2661. Now let me subtract 2661 from both sides of this equation. Then this positive value, negative value will cancel out. I am getting x square negative 24x negative 2661 equals to 0. So this is the equation which represents a given situation. And I find this equation in answer choice A. So the correct answer choice for this question is A. Okay, let's look at the next problem. Which of the following functions has a minimum value at negative 3? Here we have two functions and we have to find one or both the functions whether they have a minimum value at negative 3. Okay, now we can use Desmos to solve this problem easily. That is, we have to get graphs for both the functions. Okay, let me take the first function as input to get its graph. That is f of x equals to negative 6 times 3 has to be raised to the power of x negative 3. Okay, now let me take the function g of x as input. That is g of x equals to negative 3 times 6 to the power of x. Okay, here I got the graphs for both the functions. The regular one is the graph for the function f of x. Okay, when I look at the graph of the function f of x, its maximum value is negative 3. That's that we have over here. And when I look at the minimum value at the graph of the function f of x, it keeps going down. So there is no finite value as a minimum for the function f of x. So for the function f of x, this negative 3 cannot be the minimum value. So we can reject the first function. Now let's consider the function g of x. When you look at the graph of the function g of x over here, its maximum value is 0. And when I look at the minimum value for the function g of x, it keeps going down. So the same thing, there is no finite value as minimum for the function g of x. So now -3 cannot be the minimum value for the second function g of x as well. So we can reject this one. So the correct answer choice for this one is neither 1 nor 2. Here we have the next problem. Okay, let's go to the question. In the xy plane, a parabola has vertex 9, -14 and intersects the x-axis at 2 points. If the equation of the parabola is written in the form y equals to ax squared plus 2bx plus 2c, where a, b, and c are constants, which of the following could be the value of a positive, b positive, c? Here we have the vertex for the parabola, and the quadratic function is given in standard form. When we have a quadratic function in standard form like this one, there is a formula to get the x-coordinate of the vertex, that is -b divided by 2a. And here the x-coordinate of the vertex is 9. Let's plug in this 9 now for x over here. Then we get 9 equals to -b over 2a. Now let's solve for b in this equation. Let me multiply both sides of the equation by 2a. Then this 2a will cancel out. I am getting 18a equals to -b. Now let's multiply both sides of this equation by -1. Then I'm getting -18a equals to b. And here, this point, actually the vertex is on the graph of this quadratic function. Since we have this point on the graph of this function, we can plug in this x-coordinate 9 for x over here, and y-coordinate -14 for y over here. Okay, now let me do it. Then we have -14 equals to a times 9 square positive b times 9 positive c. Then we have -14. When I simplify this one, that is the value of 9 square is 81. We get 81a positive 9b positive c. -14 equals to 81a positive. And for b, we have -18a. So let's plug in this -18a for b over here. Then we have positive 9 times -18a positive c. Okay, now let's solve for c in this equation. Let me continue over here. -14 equals to 81a. Positive times negative is negative. Okay, now let me multiply 9 and 18. I am getting 162a positive c. Okay, -14. When I combine this 81a and -162a, I am getting -81a positive c. Let me add 81a to both sides of the equation. Then this one will cancel out. I am getting 81a, -14 equals to c. Okay, here our aim is to get the value of a positive, b positive, c. Okay, now let me write over here a positive, b positive, c. We can keep this a as it is, and for b already we got the stuff, that is -18a, and for c we got this stuff, that is 81a, -14. Then we have a positive, b positive, c equals to, when I combine the like terms over here, I am getting 64a. We can write this -14 as it is. Okay, now let's consider the information we have in the question. The parabola has vertex 9, -14, and it intersects the x-axis at 2 points. Okay, now let me draw an xy plane over here, and let me plot the vertex 9, -14. Let's take the positive value 9 on the x-axis over here. This is y-axis and this is x-axis. Now let's take the y-coordinate -14 over here. Okay, so here we have the vertex 9, -14. Since the parabola intersects the x-axis at 2 points, it must open up so that the parabola will intersect the x-axis at 2 points. Since the parabola opens up here in the given quality function, the leading coefficient a must be positive. Okay, here in this equation, a must be positive, and in the given answer choices, we have values for a positive, b positive, c. Okay, now let me take the value in answer choice here, that is -23. Now let me verify whether this one is correct or wrong. Let's plug in this -23 for a positive, b positive, c over here. -23 equals to 64a, -14. Okay, now let me add 14 to both sides of this equation. Then this -14, +14 will cancel out. When I combine these two numbers, I am getting a 9. I'm sorry, -9. On the right side, we have 64a. Let's divide both sides by 64. When I do so, this 64 will cancel out. Anyways, I'm getting a negative value for a, but that's not possible. Just now we discussed, since the parabola opens up, the leading coefficient a in the quadratic function must be positive. So when I take this negative 23 as a value for a positive, b positive, c, I am getting a negative value for a. So we can reject answer choice a. Now let me consider the value I have an answer choice b. Let's plug in negative 19 for this one. Then we get negative 19 equals to 64a. Negative 14. Okay, let me add 14 to both sides. When I do so, this one will cancel. We get a negative value on the left side. On the right side, we have 64a. Anyways, we get a negative value for a. It doesn't matter what value we get for a exactly. So when I divide both sides by 64, I'm getting a negative value for a. So when I consider the value I have an answer choice b, that is negative 19 for a positive, b positive, c. A is negative, so we can reject answer choice b as well. Okay, now let's consider negative 14 for a positive, b positive, c. Then we get negative 14 equals to 64a, negative 14. When I add 14 to both sides, I'm getting 0 equals to 64a. So when I solve for a in this equation, I'm getting a equals to 0. That's not possible. If a equals to 0, then we will not have a quadratic function over here. Then we will not be getting the graph parabola. So the value we have in answer choice C, that is this negative 14, cannot be the value of a positive, b positive, c. We can reject this one as well. Okay, now let's consider the value negative 12 in answer choice D. Let me plug in over here. 64a, negative 14. When I add 14 to both sides, I am getting 2 on the left side. On the right side, we have 64a. So even when I divide both sides by 64, I am getting a positive value for a. So when this negative 12 is the value of a positive, b positive, c, the leading coefficient is positive. So in the given answer choices, the value negative 12 in answer choice D could be the value of a positive, b positive, c. So the correct answer choice for this question is D. Here we have the next problem. Okay, let's go to the question. The functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations are displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? Here we have two functions. The first one is f of x and the second one is g of x. Now we can use the Desmos to solve this problem. Let me take the first function f of x in Desmos. That is f of x equals to 33 times 0.4, and it has to be raised to the power of x positive 3. And for both the functions, I have the same domain, that is x greater than or equal to 0. Now let me take the domain for the first function f of x. Okay, now let's see where we have the graph of the function f of x over here. Okay, here I got the graph. Now let's consider the maximum point we have over here. That is 0, 2.112. And now to get the maximum value of the function f of x, we have to consider the y-coordinate of this maximum point. Because we know that y equals to f of x. Okay, here the y-coordinate is 2.112. So this is the maximum value of the function f of x. Now we have to check whether this value is displayed as a constant or coefficient over here. No, it is not. So the first function f of x does not display its maximum value as a constant or coefficient. We can reject the first one. Okay, now let me take the second function as input. That is g of x equals to 33 times 0.16 and times 0.4. It has to be raised to the power of x negative 2. And for this one also we have the same domain, that is x greater than or equal to 0. Okay, now let's look at the graph here. It keeps going up. We need the maximum value for the function g of x. Okay, here we have the maximum point of the function g of x, that is 0, 33. And the same thing, to get the maximum value for the function g of x, we have to consider the y-coordinate, that is 33. 33 is the maximum value of the function g of x. And this 33 is displayed as a coefficient over here. So the second function g of x displays its maximum value 33 as a coefficient. The correct answer choice for this question is B2 only. Okay, let's look at the next question. The function f is defined by f of x equals to ax square positive bx positive c, where a, b, and c are constants. The graph of y equals to f of x in the xy plane passes through the points 7, 0 and negative 3, 0. If a is an integer greater than 1, which of the following could be the value of a positive b? Okay, here we can consider the given function. It is a quadratic function in standard form. When we have a quadratic function standard form, there is a formula to get the x coordinate of the vertex. So that is x equals to negative. We have to consider the coefficient of x b, and it has to be divided by 2 times the coefficient of x square. That is 2a. And the graph of the given function passes through these 2 points. In both the points, the y coordinate is 0. Since the y coordinate is 0 in both the points, these 2 points represent the x-intercepts of the graph of this quadratic function, I mean the parabola. Okay, when we have the 2 x-intercepts of the parabola, to get the x-coordinate of the vertex, we have to find the average of the x-coordinates of the 2 x-intercepts. Okay, now let's find the average of the 2 x-coordinates, 7 and negative 3. Then we have to add these two numbers and divide by 2. Okay, then we get 7 negative 3 divided by 2. We get 4 over 2, which is equal to 2. Here I got the x-coordinate of the vertex of the quadratic function. So now we can plug in this 2 for x over here, because this is the formula we have to get x-coordinate of the vertex. Then we have 2 equals to negative b over 2a. Okay, now let's multiply both sides of the equation by 2a to solve for b in this equation. This 2a will cancel out. Then we get 4a equals to negative b. Now let's multiply both sides of the equation by negative 1. Then I'm getting negative 4a equals to b. Here I got the value of b in terms of a. And our aim is to get the value of a positive b. Okay, now let me write the stuff over here, a positive b. And we can keep this a as it is. And for b, we can plug in this one, negative 4a. Then we have a positive b equals to negative 3a when I combine a and negative 4a. Okay, now let's consider the given answer choices. In each answer choice, we have a value for a positive b. Okay, now let's verify the given answer choices one by one. Let me consider the value negative 6 in answer choice a. That is, we have to verify this negative 6 could be the value for this a positive b. So let's plug in this negative 6 for a positive b over here. Then we have negative 6 equals to negative 3a. Let me divide both sides of this equation by negative 3. Then this negative 3 will cancel out. A negative will cancel out. 6 divided by 3 is 2. On the right side, we have a. Here I got the value of a, that is 2. But there is a condition given in the question for the value of a, that is a is an integer greater than 1. Here the value we have for a is 2, which is an integer and also greater than 1. So this value of a satisfies the condition given over here. So this negative 6 in answer choice a could be the value of a positive b. So the correct answer choice for this question is a. Anyways, we can verify the other answer choices as well. Now let me consider negative 3 in answer choice b. Let me plug in this negative 3 for a positive b over here. Then we get negative 3 equals to negative 3a. Let's divide both sides of this equation by negative 3. This one will cancel out. The simplification of this one is 1. On the right side, we have a. Here we have a equals to 1, but it does not satisfy the condition given over here. That is, a is an integer greater than 1. So since this value of a does not satisfy the condition given over here, the value negative 3 in answer choice b could not be the value of a positive b. We can reject this one. Now let's consider the value we have in answer choice c, that is 4. Let me plug in over here. Okay, let's divide both sides by negative 3. This negative 3 will cancel out. We get negative 4 over 3 equals to a. So the same thing, so it does not satisfy the condition we have over here. So a must be an integer greater than 1. Here we get a negative value, and also it is not an integer. So this 4 in answer choice C could not be the value of a positive b. And let's plug in this 5 for a positive b over here. Then we have 5 equals to negative 3a. Let's divide both sides by negative 3. Then this negative 3 will cancel out. We get negative 5 over 3 equals to a. Again, the value we have for a over here does not satisfy the condition given. So this 5 could not be the value of a positive b. So the value negative 6 in answer choice a could be the value of a positive b. Okay, let's look at the next problem. The function h is defined by h of x equals to a to the x to the power positive b, where a and b are positive constants. The graph of y equals to h of x in the xy plane passes to the points 0, 10 and negative 2, 325 over 36. What is the value of ab? Okay, now to get the value of this a times b, we need to find the values of the two constants a and b in the given function. And since we have y equals to h of x, we can plug in this y for h of x over here. Then we get the equation y equals to a to the x to the power positive b. Now we can use the Desmos to solve this problem. Okay, now let me take the Desmos. In Desmos, first I have to give the 2 points we have over here as the input. Okay, for that we have to click on this positive sign, go to table. So the first point is 0, 10, and the second point is negative 2, 325 divided by 36. Now we have to give this equation as input, and my aim is not to graph the equation. My aim is to get the values of the two constants a and b in this equation. In that case, when I take this equation in Desmos, instead of y, I have to take y1, and instead of x, I have to take x1. Instead of equal sign, I have to take tilde sign. Okay, now let me type y1. Then we have to take tilde sign. It has to be raised to the power of x1, x, and we have positive b. Here I got the values of a and b in the Desmos. A equals to 6 and b equals to 9. And our aim is to get the value of a times b, that is 54. Okay, here we find 54 in answer choice C. The correct answer choice for this question is C. Okay, let's go to the next problem. The table shows 3 values of x and their corresponding values of y, where y equals to f of x positive 4 and f is a quadratic function. What is the y-coordinate of the y-intercept of the graph of y equals to f of x in the xy plane? Okay, for this function f of x, we have to find the y-coordinate of the y-intercept. Okay, now let me consider this equation, that is y equals to f of x positive 4. Since f over here is a quadratic function, so this complete stuff will represent a quadratic function. So we can write this quadratic function in standard form, that is y equals to ax square positive bx positive c. Okay, now to get the y-coordinate of the y-intercept of the graph of this function f of x, first we have to get the function f of x. For that we need the values of the 3 unknown constants a, b, and c over here. And here in the table we have 3 values for x and 3 values for y for this function. I mean for this one, y equals to ax squared positive bx positive c. Now we can use Desmos to solve this problem. Let's take the 3 points in the table in Desmos. Okay, click on this positive sign, go to the table. So the first point is 21, negative 8, and the second one is 23, 8, and the third one is 25, negative 8. Okay, now what we have to do is we have to take this function in Desmos, and my aim is not to graph this function. My aim is to get the values of the unknown constants a, b, and c. In that case, when you take this one as input in Desmos, instead of y, I have to use y1. Instead of x, I have to use x1. And for equal sign, I have to use a tilde sign. Okay, now let me take this function as input in Desmos over here. That is y1. Then we have to take tilde sign, a times x1 squared, and positive b times x1 positive c. Here I got the values for a, b, and c. So that is, now let's rewrite this function. That is a equals to negative 4. Then we have negative 4x squared. And for b, we have 184. That is 184x. And for c, we have negative 2108. Okay, here we got the stuff for f of x positive 4. Okay, now let me write over here f of x positive 4 equals to this stuff. Negative 4x square positive 184x negative 2108. Our aim is to get the function f of x. So we have to get rid of this positive 4. Let me subtract 4 from both sides of this equation. Then this positive 4, negative 4 will cancel out. We get f of x on the left side. On the right side, we have negative 4x square positive 184x. When I combine these two negative values, I am getting negative 2112. Okay, I got the function f of x. Since our aim is to find the y-coordinate of the y-intercept, we have to plug in x equals to 0. Because always the x-coordinate is 0 at the y-intercept. So now to get the y-coordinate, we have to plug in x equals to 0 into the function f of x. Okay, now let me plug in 0 for x. When I plug in x equals to 0, over here this term will become 0 and this one will become 0. Negative 2112. So finally, I'm getting negative 2112. So the y-coordinate of the y-intercept of the graph of this function is negative 2112.